Good afternoon, everyone. Today we start our unit on quadratic functions. I'm going to title today's lesson Families of Functions because we're going to be contrasting two different families of functions, the linear functions and the quadratic functions. So we'll be doing quadratic functions versus linear functions. You already know a bit about quadratic functions because most of our first semester, you already know a little bit about linear functions because most of our first unit was spent on linear functions. And as I go through, I'm going to remind you of what a linear function is and then introduce you to the quadratic function. So a linear function, remember, can be graphed as a line. The word linear has the word line in it. And the standard form of the linear function is ax plus by equals c. And the important thing here is the exponent on the variable. The highest exponent is 1. We're going to write in here that the highest exponent is 1. Okay, a quadratic function, on the other hand, has a standard form of y equals ax squared plus bx plus c. And the important part to notice about a quadratic function is the x squared. Okay, the highest exponent in a quadratic function is going to be 2. So the highest exponent is 2. So the way we tell the difference between a linear and a quadratic function based on the equation is by the exponent. Okay, let's look at some examples of some linear equations. I'll just give you a couple examples of linear equations. We could have y equals 4x plus 7. That's linear because the highest exponent on the variable is a 1. We could also have y equals negative 2x. That would also be linear because, again, the highest exponent on the variable is 1. So let's look at some examples of quadratic equations or quadratic functions. So we could have something like y equals 4x squared minus 2x plus 3. The highest exponent in this equation is a 2, so that makes it quadratic. Or we could have y equals 1/2 x squared. Again, the highest exponent in the equation is a 2, so this is quadratic. So what does the linear parent function look like? Remember, the parent function is the most basic function in the family of functions. So the simplest linear function is just y equals x. What does the quadratic parent function look like? The simplest quadratic function in the family of quadratic functions is y equals x squared. So we call that the quadratic parent function. So how are the graphs different? A linear graph I'm going to zoom in a little bit here. A linear graph is always a line. Okay, so the graph of a linear function is always a straight line. A quadratic graph has a shape that we call a parabola. And a parabola is basically a U shape. So a quadratic graph is a parabola. And I'll draw a parabola on here for you. A quadratic graph is a parabola. Okay, how about the table? Let's just look at this table right here. We're going to look at the difference in the x values and the y values. As we go down the table, x is increasing by 2 every time. And as x is increasing by 2, y decreases by 6, and then y decreases by 2, and then y increases by 2, and then y increases by 6. This column right here we call the first difference. And in a quadratic equation, or a quadratic function, the first difference is not the same. Okay, so this is called the first difference. However, if we look at the second difference, this time we are increasing by 4, and then increasing by 4 again, and then increasing by 4 again. So in a quadratic function, the second difference is constant or the same. So this second column we call our second difference. And in a quadratic function, or a quadratic table, the second difference is always the same. So we can say that a quadratic table always, I'm going to skip the word always just to save some space. So a quadratic table has a constant second difference. A linear table, on the other hand, is going to have a constant first difference. So a linear table, in a linear table, this first column is the same. So a constant first difference. Okay. So now we have contrasted quadratic and linear functions a bit. Let's go on to our second page and just talk about the parts or the characteristics of a quadratic function. A quadratic function always has a vertex. And a vertex is going to be the ordered pair that is the highest or lowest point on the parabola. So in this parabola right here, the vertex would be right here. So the vertex is going to be the highest or lowest point on a parabola. Okay, and if it's the highest point, we call it a maximum. If it's the lowest point on the graph, we would call it a minimum. So a vertex is either a maximum or a minimum depending on where it is on the graph. If it is the highest point, we call it a maximum. If it is the lowest point, we call it a minimum. In this graph here, the coordinates of our vertex are -4 and 9. And our vertex is a maximum. We can say that the function has a maximum value of 9 because that is the highest y value on the graph. Okay, a parabola also has an axis of symmetry. An axis of symmetry is just a vertical line that divides the parabola in half. Okay, and we can often refer to the axis of symmetry as the AOS for short. Okay, so this is a vertical line that divides the parabola in half. And the equation of the axis of symmetry is always an x equals equation. Because remember, a vertical line crosses the x-axis, so it always has an x equals equation. So the equation of this AOS, or axis of symmetry, is x equals -4. Because every point on this line has an x-coordinate of -4. Okay, a parabola also has roots. Roots are the points where the parabola crosses the x-axis. Okay, so roots are where the graph of the parabola crosses the x-axis. Okay, roots are also known as, some other names for roots are x-intercepts, zeros, or solutions. All of these words mean roots, and we'll be using them interchangeably throughout the unit. Why do we call them zeros? Because they are on the x-axis where the y-coordinate is always 0. So the y-coordinate of the root is always 0. A parabola can have one root, meaning it touches the x-axis one time. It can have two roots, meaning it touches the x-axis two times, or it can have zero roots, meaning it doesn't touch the x-axis at all. This particular parabola has two roots. And the coordinates of its roots would be -1, 0. That would be this point right here. And -7, 0. That would be that point right there. Okay, let's do a quick example before we're done. Let's identify the parts of this parabola. Okay, this parabola has a vertex at the ordered pair 1, -9. And that vertex is a minimum. The parabola has a minimum value of -9. A minimum y value of -9. The axis of symmetry of this parabola is x equals 1. So our AOS, or our axis of symmetry, is x equals 1. And notice that the axis of symmetry has the same value as the x-coordinate of the vertex. This parabola has two roots. It crosses the x-axis in two places. It has a root at -2, 0, and it has a root at 4, 0. That concludes today's lesson. We'll see you tomorrow in class.